Hi guys, I hope you're good since last video. So this video is a follow-up of a very recent video that we have posted about DeepSeek-OCR. We're going to generate our own PDF, chunk it, and try to run some retrieval on it. Let's get started. Version 1, attention at 1024 dimension, and after we're going to do the compression back to 256 dimension. Is not following 100% the paper, so this is how the paper was, but we are going to make the code evolve and we're going to run some different versions. So this is what we've seen in the previous video about DeepSeek-OCR. They are able to extract, tokenize and compress through their deep encoder, and we've seen those different keywords. That's what we are going to try to represent in a more, like in an easy way for us. Different steps. Here we have PDF to image. We're going to do a 16 by 16 that we're going to split again 4 by 4 to get 64 by 64, so 4096 tokens. And after that we're going to use the visual encoder, MobileNet v3 small, to get those 256 dimension tokens, widen to 1024 dimensions, self-attention over 4096 tokens at 1024 dimensions, and after that we're going to compress it back to 256 dimension. So that was the easiest way for me to make it at the beginning, but after we're going to make it evolve, we're going to come closer to what the paper does, and we're going to do a dual retrieval using mini-LM and OpenClip, vision model, and another ones for the text, and we're going to use hybrid scoring. For that I'm just going to copy it because I forgot to add it into the diagram here, and we're going to also get the top results, so the top 3 best. We're going to just go for the 3 best answers, and from that we're going to get this hybrid scoring. Okay, so let's go through our version diagram. Extract, generate PDF, PDF to image. So for that we're going to chunk it in the encoder 16 by 16, split it 4 by 4. Okay, and the heat map also that I forgot to tell you that we're going to also be creating. So in the retrieval here, the user is going to make a query, he's going to get a report, but we're going to be creating also a heat map. So generate PDF, PDF to image, we chunk it, we split it, we get our 64 by 64, so far 1096 token, we tokenize, visual encoder, 256 dimensions, expand to 1024 dimensions, we do the self-attention on it at the same dimension level, 1024. So in the paper they're doing it at 256 dimension, and they do the expansion before. After here we're going to compress to 256 dimensions on the retrieval OCR page, mapped onto those microcells, 4 by 4 cells, because we got a grid now of the document. Dual retrieval, text, mini-LM, and vision OpenClip. And from that vision OpenClip we can make the heat map on the document, and we get also the top results, hybrid scoring, and we have our Olyama agent. We're going to use Quinn, little question, and after here user query, and it's going to get a markdown report, human friendly. The human behind doesn't need to know all this process, and we're going to see how it's going to be done. So why I did that? Because I needed to see and understand more. So that's why I did this experiment. So you're going to need to install Tesseract OCR into your Linux environment, and after in the virtual environment you need to create a Python virtual environment and install Torch Vision audio, and the CPU version, because here we're working only locally. CPU computer, we don't have much resources, and after you need to install those different dependencies by Tesseract. That's why here we need Tesseract OCR in the Linux environment, by MuPDF and so on, Pillow, OpenCV, Python, Headless, NumPy, Scikit-Image, Matplotlib, request, TQ, DM, and so on. So you create your environment, you install that, then you are ready. After, you can generate your requirements, the TXT, by just running your pip phrase. So you get all those dependencies with their versions, and you can push it to Git. So here, I'm also using an Olyama. So for the installation, you need to install Olyama, okay, using the curl command, just one single command and it will be installed. After that, maybe you don't need the Olyama serve, you can straight away go into the Olyama pool and you pull a model. Here, I don't have much resources, I want it to run quick. It's just an experiment, doesn't have to be perfect, but I need to see the different steps. So I'm just getting Qwen 2.5, 1.5 billion instruct. Okay. So our test PDF. So I have a script to generate a PDF. Let's just go to the folder here. And this is the one, generate PDF.py. Okay, so here we're using those imports. I'm just going to go quick into the code. I'm not going to go into the details. We get a title, Mangakisa report. We just want to see the influence, how many people are coming in, the reservation seats, the time slots, and we're going to try to make also a graphical representation, randomize graphical representation. It's just to have a PDF, one page, simple to read. Activate the virtual environment, and I'm going to generate this PDF. We can maybe open the PDF. Let's go into the folder. And where is it? Here. That's the first version of the PDF. So that's the second version. That's the first version of it. So I've done this video to the end, but I got some trouble, so I had to redo it. That's why you will see me in this video regenerating this PDF at one moment. So from this first run, that's the one which is not really like in the paper. That's why I just kept this part so that you can understand the process. Okay, so here the statistics. So we get nice table, we get nice here graphical representation of it, those bar charts, and we get a little sentence at the end, just telling that the busiest hours are in the evening, and the stack sales correlate with the total attendance and so on. Okay, and that's our assistant. I've prepared this document. Okay, Mangakisa Shibuya daily activity report. So based on that document, the version 1, attention at 1024 dimension, and then we're gonna get the compression done. While I'm running the code, we'll be able to see printed the different steps that we're gonna go through. So I have different folders for the different versions that we're gonna run. So let's go for this one. So I've run it before, so that's why you can see all the result files, but we're gonna run it again together. Here are the steps, those are the agents, and this is the command that I'm using. So I've set different flags, get those parameters. Okay, so I just need to change maybe this one here, or maybe I'm just gonna copy the file I've generated into this folder, so that we have the right file. We run it on the file that I showed you. Okay, so here the file name is different. So we have the PDF, we have a query, evening attendance and snack sales. The beta here, I'm going to put it at 0.3. Okay, Olyama, we call it Olyama agent with those different parameters, the model, the context, and so on. The top end sales, this is, I just leave it like that for the moment, 60%. So that's what will be filtering the best score. So here I put it at 60% for the score, but I found that 54% was better for my setup. And here we can start seeing the steps. First, we raterize the PDF to be able to build the 16 by 16 that we're going to break down into 64 by 64 micro grid. So we get those patches, 4096, visual encoder, 256 dimensions, and after here we're going to wait together. I have fast forwarded the parts that takes more time because the models need to be downloaded. And after here, so it has been fast forwarded here. It takes more time to get those tensors. After here we read them from 256 to 1024 dimensions. After the 4096 tokens self-attention at 1024 dimension, we compress back to 256 dimensions. We do the OCR on those micro cells because we have the coordinate of those cells. And after, we're going to get the embedder plus scoring all those different patches. And after here, the profiler top end by text for clip encoding. That's the download of this model weights, but yeah, it's going to be also fast forwarded. It might take a while. Let's just push the button fast forward for the video. Yes, and now encoding the candidate patches with clip image encoder. Okay, so now we got our table. Okay, scoring, causing similarities, hybrid scoring with top K selections, the top 3 selected. We get here the best one, the best index and hybrid score 62%. So is at 62% this one. And we just write here the snippets, observation, evening hours remain the busiest. Snack sales correlate with total. So that's the sentence that has been selected being the best in terms of hybrid score. So text and vision. So here I'm just using that to make it quick, but the best would be to use a real vision model, very smart one, and a better text model. And after here we synthesize a human-friendly answer. Let's see the top 3, how it has been represented into the document. So this is the error that I got before. So I had to run this document here that you see. So the one that I've generated before. I mixed up both. So this is the one, and you can see how the squares are created to the document. It's going to be like that anyway for the other one. And after here we get the heat map. You can see here at manga, Kisa, it went statistics, reserved, time slots, the snack sales, just to see what it has checked. Remain busiest, acceptable limits. So we got this little heat map for each models we've seen, that what it has selected, the data extracted. I just want to show you here this one, which is the denoised patch texts denoised. That's the one which is pretty to see, has been formatted, and that's how it is represented in this file. So we get a grid with different coordinates, and it tells us what are the coordinates, what is the text at each coordinate. Okay, so we can see that it could extract the text, the numbers, but we can see that is not good because there's no context to those numbers. It's just extracting like a robot. That's why here it's better to use a really good model. Agent answer. Let's see the Oliama agent answer at the end. We had feed the agent with the initial query, some of the data that I just showed you, the extraction data, and the score. This document contains detailed report on evening attendance and snack sales for the Mangakisa launch, attendance time slots, snack sales statistics. Okay, after we have the explanation, the document provides an overview of the Mangakisa Shibuya launch, usage, and so on. And after we get the time slots, so it's not really true for the time slot 6 p.m. to 8 p.m. It's 6 to midnight actually. Total attendance, this means that during peak times evening there's a higher demand for snacks, leading to increased revenue for these sales. Key finding, peak attendance, correlation with sales. Okay, so it's a small model. We can't see this as a true answer. The document provides valuable insights into the user's pattern and financial performance of the Mangakisa Shibuya launch during evening hours. It had picked up the evening hours. This information can be crucial for optimizing and so on and so on. So you've seen the steps. We provide the query. We get the different steps. We pass through those steps. And after the end, we get a report made by an agent. Please like and subscribe during the break. And that's me when the code works fine. Version 2, attention. We do it at 256 dimension, and after we do the compression. So here, 16 by 16 grid, the token. We do the same. After we do the CNN on the 256 dimension visual encoding into compact semantic features. So let me put here into the parentheses of the CNN. That's not the TV channel. It is the convolutional neural network. Okay, so we do it in step 2. Let's go back to it. So in the 256 dimension, visual encoding into compact semantic features, and after we read them to 1024 dimensions, reach capacity for token space interpolation. So we move. We do this expansion. We stretch to 4096 tokens in token space. So this is the context, the sequence length. Let me just put this in in 2 lines. Okay, so neighbor aware upsampling of a 16 by 16 token grid, producing a 64 by 64 token field And after we compress to 256 dimensions before attention, we reduce per token weight. So attention at over those 4096 tokens is cheaper. Attention at 256 dimension, long context mixing across the whole page with controlled compute. And after we do the retrieval, and we use the agent to get a nice report. So here the encoder has changed. I just put in orange what has changed compared to the version that you have run before. Chunk, you can see here, we split it at this level, but here we don't do the second split, we just chunk it 16 by 16. 256 dimensions for the tokenizer, this doesn't change. We expand to 1024 dimensions. And after here, we're going to be doing the context length. We're going to get those tokens, tokenize. When here, we did it differently. Okay, so this little square is going to change. And after we do the compression, so from those 1024 dimensions to 2056, and we do the attention over the 4096 tokens in 256 dimensions. We're coming closer to what the paper says that it does. And after here, the retrieval doesn't change. OCR on the page, grid. User makes a query, gets a report, and we get the heat map on the top 3 scores. Okay. So I generated a new PDF that you've seen at the beginning of the video. As I told you, I've messed up a bit, so I had to redo everything. So now, for sure, we're gonna work only with this PDF to the end. So let's run this version 2, which is the 256 dimension, and after that we do the compression. So we do the attention at 256 dimension this time. Okay, so let's run it together for the first time. So I'm just going to copy that PDF generated into this folder, because the one that is here is not the right one. Okay, and just let me get the command from this one here. It's the same command. After I just need to calibrate the command. The beta needs to be at 03, same as the other one. And yes, the query is the same. And here the file name is different. And we're good to run. Yes, let's go. And we're gonna do the same process. We're gonna see the step passing one by one. I'm gonna fast forward the parts that takes too much time. After, you can set an environment variable, a chef underscore home, again for its home, but I didn't. Even if I put it in the code, so the code is calibrated for that, but it's fine, as you're gonna get the fast forwarded version. So here we still rotorize, 16 by 16 microgrid, 256 dimension, visual encoder at that 256 dimension. We read in the macro level, we stretch it, we get those 4096 parts token, compress to 256 dimension, self-attention is done, 4096 token, self-attention at 256 dimension, we save the compact long context token, and after we do the OCR, mapping the 64 by 64 micro cells, and after we do the scoring, text scoring, okay. And after we get our table here, okay, scoring using same clip, causing similarities for candidates, hybrid scoring, the top key, which is I just choose 3 for the key value, 61%. Observation, let's see. So here we got the top 3. So the squares are not really onto something. I don't know why. But yeah, that's how it has gone. So that means I need to maybe select a better model. I need to improve the code and so on. So same file comparison with the previous one, 1024. So on the left side, this is what we have run just now, and on the right side is the 1024. So what I've done, I've run it again to this PDF. As I messed up, I used another PDF for the first experiment. And we can see the first experiment was more precise actually. Maybe because it was a bigger dimension, because we used a bigger dimension to do the attention. The heat map looks almost the same, you see? You get those same areas triggered. The heat map that you have run for our actual run, the one that we did now, is better because we could actually get something into the bar chart. Okay? See, so they're the same. This is not much of a difference. The agent report, let's see if it is completely changing or not. Provided data pertains to an evening activity report, snack sales. So the conclusions are almost the same. Seeing that it's in the evening, peak times at 8 p.m. So in the previous report we got 8 p.m. also, mention of it. Just let me see the PDF at the same time. Okay, there's no 8 p.m. mentioned anywhere. So we have 6 p.m. to midnight, but there's some hallucination going on here. That's what you can see. So maybe with this kind of experiment, it's better to use Grok so that you can have access to those open source models, which are a little bit more powerful. Like GPT-OSS, for example, maybe would be able to do a better job. And you get a blazing fast inference. You don't need to wait. Get your report done straight away. So we can see here that the numbers are not being reflected. You see, we have the time slot, reserved seats. We have some numbers, but that's not the right ones. Okay. Okay, it got all the labels together. Coffee, ramen, manga set, and dessert. All after here for the conclusions. This correlate is relevant to figure 1, where snack sales increase has total attendance rises. The reservation system performed. Okay, so it couldn't get this bar chart proper. It couldn't get what is represented into the bar chart. Okay, so that's the report for the second run, where we've done that at 256. Please like and subscribe during the break. When the code works, you can dance. Vision 3, the version 3, we're gonna see it's almost the same as the version 2, so that's why I don't show you any diagram. What changes here is the improvement in the code, trying to feed the code with more of the files generated, having some data. I want it to be digit aware, so that's why I call this one digit aware, because I want to see if it is able to represent those digits in a smart way. So I played with the prompt a bit. We will see what's going to be the result. I'm just going to get the same query here. And we're going to run it again with this improved version, which should be digital error. So for the confidence here, I go for 54, which is 54%, the confidence score. That's something that and here the top sales have increased it to 300. I'm just trying to get more data out of the results. Okay, so before here it was defaulted at 60%. Okay, so that's why I have added this flag so that I can control the confidence score using this flag. So that's part of the improvement of the code. So this is just to get more data. Okay. So I'm expecting here to get more into each of those generated files, so that when the agent is fed with those information, having more data, it might be able to get us a more qualitative reports at the end. So basically this is what you need to do in order to see how it works, how to improve stuff. That's why I want you to see this kind of videos, because sometimes behind my other videos there are some different runs that I do like that, just to develop some understanding, some intuition, also we can say it like that, around that, so that I can have ideas in what I want to try next. Okay, so this is fast forwarded also. We can see that the score is going just under what it was before, just decreasing. Attendance, reservation summary, and snack sales statistics for the last 24 hours. Observation, evening hours. Okay, so we got those snippets, the different scores. So now let's see the top 3 representation of this. How does it look like? Now it's better. It's more precise and targeting some words, not in the white area. Statistics, busiest, snack. This is correlating with our query. We have the heat map. The heat map, manga kisa, statistics, time slot, reserve seats. Yeah, it's almost the same. Huh? We maybe have one extra point. Busiest here also, and acceptable limits. Okay. Maybe this needs to be run several times. Let's see the report. So agent answer. The provided data pertains to an evening activity. This is the same. Okay, the attendance analysis per hour, reservation system. Okay, now it's trying to give us some statistics. Okay, he got it right. 6 to midnight with an average occupancy of 79.3%. So this I don't know if it is true. Reservation system performance 65.1%. Okay. So I don't know where he got those numbers from, which calculation it has made. Let me see the document. How can you get 79%? I don't know. Okay. After here, the snack sales, total attendance 60 units. We get more numbers, but coffee here, all the different items have been put in one sentence because that's how we retrieved it. We have 42 reserved seats, 96 visitors. So yeah, can't yet rely on those numbers. Coffee, ramen, manga set, dessert, and the soft drinks. Maybe you got 60 from this one here in the graph. Yes, maybe you got it from here for the 60 units. So he's mixing up those numbers, giving us the highest scoring cells. This is from the data that top 3 that he has received. Those coordinates, conclusion, the data suggests that evening hour are the most actives. Okay, the conclusion doesn't take the risk to tell us about any numbers. That's good. At least if we just get the conclusion, it's right. Please like and subscribe during the break. This is me when I'm happy and the code works fine. Version GPT-5. So what I've done, I went back into the paper, I took a screenshot of I'm going to show you this. This is the figure representing what they've done. And I just put my code into ChatGPT and told ChatGPT what I wanted to do and how to improve it in order to get it close to this representation from the paper. We can maybe zoom on it. I'm just going to find a place where I can put it. Let's put it just between those two, and we can maybe go through just to as a reminder of what they've done. PDF, patches, 16 by 16, and after local attention, tokenizer, downsample, 16 vision tokens, low activation, embedding layer, global attention, using clip, that's the deep encoder. Okay, and after there is the prompt, and after there is a system to just decode it, to read those embeddings. So in this GPT-5 PDF to image, window attention tokenizer, it's suggesting me to use SwinTiny at the Street 16 vision token on a 2D grid, and after the projection channel 256 dimension compact token width, 16 token compressor sequence via 2D average polling. Okay, so here divided by 4 or fewer tokens, global self-attention over the compressed sequence at 256 dimension, long context. Okay, so here we can see divided by 16 vision tokens, global self-attention over the compressed sequence of 256 dimension. After save the compact tokens and do OCR, map the lines to the compressed token grid, rows and columns, and after for the retrieval, it doesn't change. We just keep it the same. I put in orange what is different from what we've done in the previous version is the tokenizer, which is a tokenizing process. Window attention, SwinTiny tokenizing at Street 16, projection channel 256 dimensions. So here we've done it differently. We use another model, convolutional neural network. Get our 4096, but here no. We go into this dimension, we compact it, and after here we multiply by 16 tokens. You can see the compression. Well, here is different. Token sequence compressed via 2 dimension, and after the global self-attention over the compressed token at 256 dimension, And here doesn't change for the retrieval side when the user is prompting and how we're doing this mapping, getting the heat map and all. So run improved ChatGPT version. Let's see what is going to be, what's the result is going to be for this GPT version. So I have another folder for that. Let's go into that folder. Okay, 256 improved ChatGPT. Let's get this with the confidence score. So I'm just going to get the same query that we've run before. I'll try to add another one, tokenizer, max side, but let's keep it consistent. Let me copy the MongoKisa report PDF, so we run it on the right one. And I need to change. I could have run it like that, but I just put all in the same folder. So let me just get rid of those 2 points. Let's run it. And let's see what is going to be the result for this. So we're going to go through those steps. Those are different steps. We raterize window attention, tokenizer. So 256 dimension token at street 16. Okay, after we compress, after we do the global attention, after we save the compact token and build the row and column boxes, that's our grid. We do the OCR, we map those row and columns. After the embedding, the scoring, the clip vision scoring of compressed cells. Okay, we got the result, the score, and after now we're going to call the agent with those new data points. So the score is not that good. I don't know, it's different from what we've got before for the first sentence. The sentence is the same. So let's see how it's going to represent the top 3. Okay, I see. So now it's trying to get more. It's very stretched. Okay. From the title to the little paragraph. You see, it's like trying to link those different parts of the document. Heat map. So same for the heat map. Get those longer vertical lines. Trying to get more of what's going on. So if this was a very smart model, it would be able to do this job very easily. That's good. So after that, what you need to do is just to change the models and find the best in Hugging Face. After, you need a strong computer, a very good one. We're using a CPU only version, that's why it takes much time, and if you want to run it locally and get a qualitative run, you need GPUs. Okay, the report summarizes the usage of MongoKisa, attendance, snack sales, the hours is the right one. Okay, detailed explanation, attendance, the report indicates reservation system operates satisfactorily. This is evident from the attendance row, table 1. Okay, snack sales, significance is made, figure 1, rank 3, where it states observation, evening hours. Yeah, it's just just writing a report to write a report. There's nothing insightful. There's no numbers, no risks taken into reading those, interpreting those numbers. indicating that evening hours. So it knows that there is a table and there is a figure, at least has a differentiated that. Okay, this PDF. Let me generate a new PDF. Completely new. And I'm going to do some runs. And we're just going to use the ChatGPT version on the first version that you have run, just to do a comparison. Okay, so that's the new PDF generated. The table won't change, but the graphical representation of those bar chart is going to be changing. So we're going to run the first experiment, the one that I found being the best, but is not really following what the paper does, which is using a bigger dimension to do the self-attention, so 1024 dimension. Okay, so I'm going to rerun it, and after I'm going to run the other one in parallel, and at the end I'm going to see the difference between the results. Okay, what's going on? Yes, the first run didn't have just let me fix this, because the file name is different. It's called Creditizens OCR attention at 1024, not following paper at all. So let me put the right file name. And let's run this one. I'll just wait for it to start, and after I'm going to go and get the other one running. Okay, so I put it at 60% for the confidence interval, the confidence score, and I'm gonna just use the right mangakisa file, which is the one in this folder. So all the copy and paste and everything, changing the folder, I've done it. I'm just trying to show you how it is when it, yeah, this is the right file name. So what's going on? Ah, yes, I forgot to activate here the virtual environment. That's why it doesn't recognize the module NumPy. So let me just activate it. So this is another time when I came back and just told to myself, let's try to regenerate and run it again, and just to see what's gonna happen. Okay, so both are running. I can't do anything else in my computer anymore because they're running together, taking all the resources, especially Oliama. Okay, let's go to the 1024 and see the results in terms of top 3. Okay, you see we still get it on the white coordinates. There's no text, there's nothing. It's not very precise for that. Heat map. Okay, we get those 3 points. Okay, let's see the report for the 1024 agent answer. So NVIM agent answer. Okay, the provided data, daily reports, peak hours, correlation, reservation. I found the first one just giving me the better reports. Table 1 provide the breakdown visitors, time slots, hours, consistency, busiest rank, snack sales, statistics. Okay, figure 1, observation, the busiest in the evening. We get the clip score, okay. Conclusion, the data highlights the evening hours are the most popular for the visitor and coincide with higher snack sales. The reservation system appears. Okay. So the system is not good enough to read the graph. Let's see the report in the other side. Total attention. The report indicates that the manga is heavily utilized during the evening. So there's no conclusion anymore. Last one, trying another query. So we didn't see any improvement. I'm just going to try to change the query completely for a sentence, which is a bit longer than normal, in which I'm going to inject some numbers just to challenge it and see how it's going to be going. We're just going to go with the ChatGPT version. I want to reserve for 29 people when not busy, so not more than 25 people reserved. I just put it, talking like a robot a little bit, because I expected just to get the keywords from my query and be able to search those words, gather the data around those words, and after we get the LLM at the end, which is going to be able to synthesize everything, having the initial query, all the data gathered around it, and the prompt that I gave to that agent. Okay, let's try to run it without any errors. What's going on here? Confidence score unrecognized. Okay, let me get rid of this. Okay, so finally I'm going to run both together with this query. I said I'm going to run only the ChatGPT one, but I'm going to run again the first one that we've done, the 1024, and versus the ChatGPT one. So I have fast forwarded. Now it's done. We get more numbers. This is the 1024 dimension one. Retrieval, the top key. The main task is to reserve seats for 29 people when not exceeding 25 reservation. And after here we get some coordinates. Okay. So it's reading more from the data given by those by those tables, those JSON files. Okay, the rank, I want to see just the conclusion. Given the score and snippet provided, the top ranked snippet indicates that the reservation system operates within acceptable limits, and so on and so on. It's recommended to focus on, so it didn't give me an answer. Okay, so big cross on this one. Yeah, you've seen the projection here of the top 3, and here the heat map. No improvement. But it didn't do worse than before. It just kept doing the same. So when it's like that, maybe the code needs improvement also. So here, let's see the ChatGPT version for that. What does it say? So attendance and reservation, the report showed that there were no reservations exceeding 25 during any part of the day. This is a big lie. And so on. And given the denoise cells, it's clear that there were no reservations exceeding 25 people throughout the day in Mangakisa Shibuya. Okay, here it's complete fail also. But at least it took the risk to talk about this 25 people, the number, and use it in its answer. And same here as using the same system as we've seen before. Yeah. But it's touching different points. Let's go quickly over the functions that are running through this all the code snippets. So we're going to just see the names of the functions. I'm going to pass through it very quickly. The names are very explanatory, so you'll be able to understand what's going on. Let me just find one of those files. Yes, this one. So let's pass those comments. This is the GPT-5 version 1. It's almost the same as the previous ones, just some part of the code are changing. Those environment variables that can be set for the environment. After here we have the parser of the arguments, input arguments, so that I can use those flags. After here, PDF to image function. We have make grid boxes, pad to multiple of 32, because I got some issues. Swing token. This is the GPT provided one, because that's the one it has suggested. Compress token 2D, and after here the self-attention one. This is a class, there's a function inside. After here we have save tokens, clean the text. Here we are more into the OCR side, OCR page, and we're patching it. Build the text embedder is the retrieval side. We build the clip. We compute clip image embeddings from the boxes, different grids. And here the visualization, draw top key boxes, draw score heat map, and after here the pretty print, truncate, print top key table, maybe the main, right answer summary, and after build agent context, and after that the agent is going to use that when we do call Oyama, where we have default values, temperature 0.2, and the main running everything. Okay. Okay. So when the code works fine, this is how we move. Would be fortunate to do our school. Even the teacher is dancing with them. Okay. So we've seen how to try to run this experiment in your local computer. After this gives you the intuition and gives you the knowledge in what you need to improve in your code. After now we're living in times in which we can use AI to help us, which is great. So you use a special model to see the different elements and create embedding from those different squares, and you use another one to get only the text, and after that you try to get a scoring hybrid of both with all the manipulation that we've done before, passing from one dimension to another. What would happen if I use the greater dimension to do this step? What would happen if I use the smaller dimension to do another step? And that's how you're going to play with the code on your experiment, improve it, and try to run it yourself to develop understanding. I believe this is the best way to learn it before going into the more fundamentals, because this gives you gives you an hint in what you need to read or research after that, because that's what you didn't understand in your code. That's what you didn't understand in the process. And coming back to it, you'll be able to improve it and to get better prompt while talking with ChatGPT, for example. So at the end, you get a better result. I would also suggest you to use maybe a remote model, not a local one. As you can see, here I have fast-forwarded parts, but it takes a while in your local computer, especially when you want to run it into a CPU-only configuration. Okay, I'm going to stop here. Hope that you like this video. Please like and subscribe, and see you next time.